2 seconds. That's straight. Okay, so this lesson's all about reasoning. It segues into what we're doing, and it just starts with this warm-up where you answer whether it's true or false. It says, if an object is red, then it's not blue. That is true. It's red, it's not blue. I guess that'll, because everybody's shuffling around. Good. Okay. Then number 2, if an object is not red, then it's not blue. If it's not red, it could be blue, so this is false. If an object is not blue, then it's not red. It could be red, so this is false. If an object is blue, then it's not red. That is true. It's blue, it's not red. Okay, then the next part, it says rewrite the statement as a true if-then statement, and it has a statement an even number is divisible by 2. So this segues into what we're doing today, so I'll just show you what it wants. An if-then statement would look like this. If a number is even, so I take like the first part, if a number is even, then it is divisible by 2. So if, then. So hypothesis, conclusion is where we're headed with this. Oh, I didn't realize it wasn't in the frame. If it's not in the frame, let me know so I can fix it. Okay, I got all my colors here. Okay, and now we're going to start filling in this chart with a lot of vocabulary that we need for this lesson. Some of these are new, completely new, and then some of them might be a little bit more familiar, but I will just start from the top. The first word is statement. A statement would be like this sentence here. It is a sentence that is either true or false. A sentence that is true or false. Statement. An example of a statement would be the sky is blue. Then a negation, we use this abbreviation like this sometimes, and we'll see that in some of our examples, just so you know. And it's the opposite of a statement. The opposite of a statement. For example, the opposite of this would be the sky is not blue. The sky is not blue. So you just take the statement and then you make it not that. And then hypothesis, abbreviated P, Y. I'm still trying to figure that out. Hypothesis abbreviated as P, and it's the if part of the statement. It is the cause. And an example would be if it rains. And just leave comma, because then the conclusion will be the second part. And then conclusion, abbreviated as Q. That's the then part. It's the effect. So the example, if it rains, then the ground is wet. Okay, before we fill this in, I'm going to go through the examples that just have to do with this, so that way it's like all together. So what we're going to do is we're going to look at some statements and identify the hypothesis and conclusion in them. So for example 1 right here, it says circle the hypothesis. So we're going to circle the hypothesis, the P part. So remember, it's if P, then Q, the conclusion. And then it says box the conclusion. So box the conclusion, the then part. Circle this, box that. So in the first example, if a polygon has 6 sides, then it's a hexagon. So the if part is the hypothesis, P part, and then box the conclusion, then it's a hexagon. That is the conclusion, the Q part. If, then. So if hypothesis, then conclusion. Sometimes, rarely, so most of the time it's in this format if they don't try to trick you. In the next one, they're showing one that's a little bit different. It says another performance will be scheduled if the first one is sold out. So notice the if is over here. So what happened is they put the hypothesis over here. So if the hypothesis, so this here is our hypothesis. If the first one is sold out, another performance will be scheduled. This is our conclusion. And we're going to flip to the back to continue practicing this for a second. Okay, so just a couple more examples. It says circle the hypothesis, box the conclusion. Okay, so if the forecast is rain, then I will take an umbrella. So if the forecast is rain, that is my hypothesis. Then I will take an umbrella. That is our Q, our conclusion. So hypothesis, P, then Q. Okay, a number is divisible by 10 if it's the last digit, if its last digit is 0. Here they put the if at the end. So this is the hypothesis right here. This is our P. Then a number is divisible by 10. So again, most of the time you'll see it in this standard format, but sometimes I do switch it up, so just be aware of that. Then for example 2, they give us this statement and we have to make the hypothesis and conclusion. So identify the hypothesis and conclusion, then write a statement in if-then form. 4 quarters can be exchanged for a $1 bill. So hypothesis, we can say if you have 4 quarters, it's our P, if P, then Q. Then you can exchange for a $1 bill. Okay, then we're going to go back to the table with the vocabulary and build from here. Okay, so then these completely new words to you. It has to do with this. So the conditional statement is P, then Q, in that order. Then the converse, you switch the order and you put Q, then P. The inverse is not P, then not Q, and I'll show you examples in a second. And then contrapositive is not Q, then not P. This right here is what you will have to memorize. This is not on any reference sheet, but it'll come up on your district benchmark, it'll come up on your semester exam, and it'll also come up on the EOC. So you must memorize this. Oh, also the chapter test that we'll take next week too. I will help you memorize it, but just know that you will be memorizing it, so the sooner you can do that. And what I mean by memorize it is get to a point where you could write this on a piece of paper just without looking at anything. And then if you can write this on your reference sheet, you can use it for any problem you get on this. So these abbreviations, this is if P, then Q. And I'll give you further examples, but just start here. If P, then Q. That's what this means. And then Q, then P. So if Q, then P. The inverse, this means negation. So if not P, then not Q. And contrapositive, not Q, then not P. If not Q, then not P. Okay, and then giving you an example for each one of these. So I chose like the shortest words and everything possible I could choose for this. If it barks, then it's a dog. So this is our P, and then this is our Q. Hypothesis, conclusion. Okay, so now that we've identified that in the conditional statement, which is usually the starting statement, then we can create the converse, which is Q, then P. So if it's a dog, then it barks. And I just switched the order there. Then the inverse, not P, then not Q. So I'm just going to take this statement and put if it does not bark, then it's not a dog. If it does not bark, then it's not a dog. And then not Q, not P. So I can take the converse, which is already in QP order, and just put not and not in it. So if it's not a dog, then it does not bark. If it's not a dog, then it does not bark. Added the not in here. Okay. Then we're going to practice this one more time with the next example. So when you get a chance, flip it. Okay. Example 3 right here. It says, it talks about a tang, and then it says, write the converse, inverse, and contrapositive of the true conditional statement. Tangs are fish that live in salt water. Determine whether each related conditional is true or false. If the statement is false, then find a counterexample. Okay, so what it wants us to do is we're going to write a conditional, converse, and this is what you need to be able to like write down from memory. Conditional, converse, inverse, contrapositive. And this is what I do too. And every year I kind of have to rememorize it because I don't keep it in my working memory. And then once I can write down those 4 words in order, then I write down, okay, P, then Q, Q, then P, not P, then not Q, and then not Q, then not P. And this order is logical to me. It's just the words. I forget the order of the words, so I have to rememorize that. And then if you can write down this, you can answer all of this. You already have your key here. Okay, so for conditional, they give us a statement, tangs are fish that live in salt water. So my conditional, if a fish is a tang, then it lives in salt water. So this is P, and then this is Q. Okay, and then converse is Q, then P, so I have to change the order. If a fish lives in salt water, then it's a tang. If a fish lives in salt water, then it's a tang. It wants me to identify whether this is true or false. If a fish lives in salt water, then it's a tang. Well, there's lots of different kinds of fish that live in salt water, so it might not be a tang, so that's false. If a fish is a tang, then it lives in salt water. That's true, because, yeah, tangs can only live in salt water. Okay, next, inverse, not P, not Q. So that's the PQ order, but we're going to put in not. So a fish is not a tang. A fish is not a tang. Then it does not live in salt water. Well, if a fish is not a tang, no, because there's other fish. That is. And then last one, contrapositive. C, contrapositive, not Q, then not P. So I'm going to say this statement, but put nots in it. If a fish does not live in salt water, then it's not a tang. If a fish does not live in salt water, then it's not a tang. That is true because tangs have to live in salt water. So if it's not a tang if it's not living in salt water. That's how to do that. And then we'll definitely practice that. It's also on Alex next week too for you to practice. Yeah, so from here, there's one more little thing to go over. So the next part, so I already have some people are still writing. Okay, the next part is called a biconditional statement. A biconditional statement can only be made if the conditional and converse are both true. In this case, one was true and one was false, so we can't make a biconditional for this. But in the next example, we can. So a biconditional statement, biconditional, bi means two, so if both statements are correct, is a conjunction of the conditional and the converse. So if the conditional and the converse are both true, we can make a biconditional statement. So here it says write the conditional and the converse, determine if they're true, and then if they both are true, we can write a biconditional. So the statement is isosceles triangles have at least two congruent sides. So to make a conditional, if a triangle is isosceles, then I'm going to use abbreviations. It has two congruent sides. That's true. Yes. By definition, if a triangle is isosceles, it has two congruent sides. The converse of that, so this would be P, then Q, and conditional is P, then Q. The converse is Q, then P. So we're just going to change the order of these statements. If a triangle has two congruent sides, then it's isosceles. If a triangle has two congruent sides, then it's isosceles. That is also true. It has two congruent sides, it's isosceles by definition. So the conditional is true, the converse is true, so we can write a biconditional. And a biconditional looks like this. A triangle is isosceles if and only if it has two congruent sides. And that's what a biconditional looks like. I wanted to have a situation where it didn't work, so that's what the next example is. And then your homework kind of looks like this with the drop downs that you fill in. So that's what this is. And I got these questions right from your textbook and just like put them in Schoology, so. Okay, so for example 2, write the conditional and converse of the statement and then determine if they are true. If they aren't true, write a counterexample and explain why you can't do a biconditional. So here it's saying the game will be canceled if it's raining. So if it's raining, that's the hypothesis. The game will be canceled, that's our conclusion, our Q. So if, then. So if it's raining, then the game is canceled. So that is true based on what it told us. The game will be canceled if it's raining. So if it's raining, the game will be canceled. The converse of that is if the game is canceled, then it's raining. If the game is canceled, then it's raining. But the thing is, a game could be canceled for a variety of reasons. It might not be that it's raining. It might be that the refs didn't show up, or a field wasn't available, or there was a scheduling issue, or whatnot. So therefore, the counterexample is the game could be canceled and it's not raining. It is not raining. The converse is false. Because the converse is false, a biconditional statement cannot be written. And this one might actually show up on your homework. I like screenshotted it from your homework. So if you get that one, that's the answer. Okay, that is all. You have the rest of class, which is a good amount of time to get the homework done. A lot of you will probably finish your homework. If you finish your homework, use the rest of the time to work on Alex. If you have all that and all your homework done, then or all your Alex done, you can ask to go and chill. And okay, go ahead and grab a laptop.